Assalamu alaikum dear students. We have to continue with Unit 5 Sets and Functions, and for today the topic is ordered pairs and Cartesian product. Let's have the introduction of the topic here.
What is the Cartesian product of sets? Let's understand this using an example of two sets. We have two sets with us. The first set T represents a set of teachers. The second set C represents a set of courses taught. So we can represent the two sets like this. Set T contains elements TA and TB, and set C contains elements English, Spanish and French. Now we want to write all possible ways in which every teacher teaches every language. We can understand this using an arrow diagram. Set T is on the left and set C is on the right. Teacher A can teach English, Spanish and French. So we draw three arrows from TA to English, Spanish and French. Teacher B also teaches English, Spanish and French. Similarly, we draw three arrows from TB. In short, we use arrows to map every element in set T to every element in set C. Therefore, an arrow is drawn from every teacher to every course. So we get TA, English, TA, Spanish, TA, French, TB, English, TB, Spanish, and TB, French. This list is complete because we get all the possible ways in which every teacher in set T teaches every course in set C. Now let's look closely at TA, English. It implies that teacher A teaches English. So our first entry is teacher and the second entry is the course. Teacher and course are separated by a comma and enclosed in round brackets. Let's use lowercase t to represent a teacher and lowercase c to represent a course. So every entry in our list is of the form lowercase t, lowercase c, where t belongs to the set of teachers T and c belongs to the set of courses C. Now, why do we use round brackets? This is because the order in which we write within the round brackets matters. Here's the explanation. Remember, we say teacher teaches course. The relation here is teaches. What if we write the first entry as course and the second entry as teacher? Is that correct? Since the relation here is teaches, it would be incorrect to say that course teaches teacher. So we cannot write the first entry as course and the second entry as teacher. From this, we can conclude that the order of elements within the round brackets matters. Therefore, every combination of teacher, course is called an ordered pair. Ordered pair implies that the order matters. It is represented using round brackets. This is the logic behind the round brackets. This complete set of ordered pairs of teacher, course is nothing but the Cartesian products of sets T and C. Cartesian products is written as T cross C. T cross C is also a set. T cross C is a set with the following elements written within curly brackets. This ordered pair is the first element, this pair is the second element, and so on. Notice that the ordered pairs are enclosed in curly brackets and separated by commas. Remember that curly brackets are used to enclose elements in a set. Here, the order of elements does not matter, whereas the round brackets are used to enclose elements where the order matters. Now we can also write the Cartesian products of sets T and C using the set builder notation. We write it like this. T cross C is equal to curly bracket open followed by T, C in round brackets such that T belongs to set T and C belongs to set C, curly brackets close. Let's look at each of our ordered pairs to see if this condition is satisfied. Now for each ordered pair of teacher, course, teacher T belongs to set T with elements TA and TB, and course C belongs to set C with elements English, Spanish, and French. Each ordered pair in the set satisfies the condition. This video gives us a basic understanding of the Cartesian product.
Let's here summarize the topic that Cartesian product is a set which contains all the possible relations between the elements of two given sets. As in this example, we have two sets, set T which represents set of teachers which contains two elements TA and TB, whereas set C represents set of courses which contains three elements English, Spanish, and French. So if we are interested to establish the relation between these two sets, so this relation can be shown with the help of Cartesian product denoted by T multiplied by C. So we can have here 6 ordered pairs or 6 relation between the elements of the sets, as we can connect in the Cartesian product every element of the first set with the every element of the second set, which is courses. So teacher A with English, teacher A with Spanish, teacher A with French. Similarly, teacher B with English, teacher B with Spanish, and teacher B with French. Since we have two elements in set T and three elements in set C, so we have 6 ordered pairs here, as 2 3s are 6. So this relation is shown with the help of ordered pairs. Why with the help of ordered pairs? Because we know that in ordered pairs the order matters. As in ordered pairs, X come first, then Y come later. Here X is the elements of set T and Y is the element of set C. So here we can say that the relation in this example is teach, that teacher teaches courses. So if we will not write or show this relation with the help of ordered pairs, so the relation then will get destroyed. Suppose if we write courses first, then teacher later, so then the relation will be that courses teach teachers. So hence the relation will get destroyed. So therefore in Cartesian product the relation is shown with the help of ordered pairs, because in ordered pairs the order matters. So hence here we can conclude that Cartesian product is a set which shows the relation between the elements of the set, and this between the elements of the two sets, and that relation is shown with the help of ordered pairs. Let's better understand here the ordered pairs, that any two numbers x and y written in the form x into y is called an ordered pair. In ordered pair xy, the order of numbers is important. That is, x is the first coordinate and y is the second coordinate. For example, 3, 2 is different from 2, 3. Remember one thing here, that if you are given two numbers written in round bracket and in between it has commas, so it means that that is ordered pair where order matters. For instance, if here we say that 3 means the first element shows the rows and the second element shows the columns, and we want to look at or we want to find the location of an object with the help of this example. So of course 3 2 will be different from 2 3, because the location of an object in the third row and in the second column will be different from the second row and the third column. So hence 3 2 is different from 2 3. It is obvious that x comma y is not equal to y comma x unless x and y is equal. If x and y will be equal, so then it doesn't matter. Here we have now Cartesian product of sets, that Cartesian product of two non-empty sets. So if there will be empty sets, so there will be no relation then between the elements. We cannot establish any relation since the sets are empty. So Cartesian product of two non-empty sets A and B, denoted by A multiplied by B, consist of all the ordered pairs x, y, such that x belongs to A and y belongs to B. the first element or the first element of ordered pair will belong to the first set, and the second element of the ordered pair will belongs to the second set. For example, we have here set A x y z and set B 1 2 3, and we want to establish the relation between the elements of these two sets. For instance, we are going to establish the Cartesian product between these two sets. So hence it can be x with 1, then x with 2, then x with 3, y with 1, y with 2, and y with 3, z with 1, z with 2, and z with 3. So hence here we have 9 possible relations. We have 9 ordered pairs here, because set A has 3 elements and set B has 3 elements. So 3 3s are 9. So the number of elements in Cartesian product will be 9. We have another example of Cartesian product here. Set A has 3 elements. You can see 3 triangles here. And set B has 5 elements. You can see 5 stars here. So if you want to show the relation between the elements of these two sets, so we can show it with the help of Cartesian product here, A into B. So we can establish all the possible connections or relations between the elements of these two sets. As we can take the first triangle from here, which is red. So red triangle can be connected with every elements of or every stars in set B. So here you can see that red triangle is in relation with yellow, then with orange, then with red, then with blue, then with green. So similarly, we have taken here now the second triangle, which is green, and we have it with blue, with yellow, then we have with orange, then we have with red, then we have with blue, then we have with green. Similarly, the third triangle, which is blue, so it is with yellow as well, then with green, then with red, then with blue, then again with green. So how many possible relations we have, or how many ordered pairs we have here? 15, because here the elements are 5 and here the elements are 3. So 5 3s are 15. So hence we have 15 ordered pairs in the Cartesian product. Let's begin with the exercise here, so you will better understand the concept. Question number 1 is here: if set A has the element A and B and set B has the element C and D, then find A into B and B into A. Means, so let's have the set A here and set B here, and we are going to find the Cartesian product here, A into B. So this is set A and this is set B. We are, since Cartesian product is also a set, so therefore we are going to put the curly bracket, and inside the curly bracket we are going to show the ordered pairs, I mean the elements of the Cartesian product. So let's have the relation of first element with the elements of second set, A with C, then A with D, then now B with C and B with D. So here we have 2 elements and here we have 2 elements, so 2 2s are 4. So hence we will be having 4 ordered pairs in Cartesian product. Next we have B into A. So since B set is written first, so B set, then A set. Now C with A, then C with B, then D with A, and D with B. So we have 4 ordered pairs here in Cartesian product. Question number 2, we have here set A has the elements 0, 2, 4 and set B has the elements -1 and 3. Then we have to find A into B, B into A into A, and B into B. So we have 4 parts here. First of all, the first part, A into B, set A is written first, then multiplication sign, and set B is written as -1 and 3. Now we can see that here we have 3 elements and here we have 2 elements. So we will be having 6 ordered pairs here. So 0 with -1, then 0 with 3, then 2 with -1, 2 with 3. Okay, here it is not written. Let me write it for you. 0 with -1, then 0 with 3, 2 with -1, and here one element is missing. 2 will be with 3. Now 4 will be with -1 and 4 will be with 3. So hence we have how many? 6 possible or 6 ordered pairs in Cartesian product of A into B. Next is B into A. So set B is written first, then set A. Fine. So we are going to -1 with 0 will be -1 will be with 2. Then okay. then minus 1 can be with 4, now 3 will be with 0, then 3 will be with 2, and 3 can be related with 4 or can be connected with 4. So here again we have 6 ordered pairs in B into A. Now again the same question, and we are going to find A with A. So A set should be written, then multiplication sign, again set A should be written. Now we are going to write all the possible ordered pairs here. So 0 with 0, you are not going to multiply, you are just going to relate or connect it. 0 with 2, then 0 with 4, then 2 with 0, 2 with 2, and 2 with 4, then 4 with 0, 4 with 2, and 4 with 4. So how many we have the ordered pairs here? 9. Next is B into B. Minus 1 means B should be written 2 times here. Minus 1 with minus 1, minus 1 with 3, 3 with minus 1, and 3 with 3. So we have here 4 ordered pairs. Question number 3 is that we are going to find out the unknown values A and B if we are given these ordered pairs. Since here is the equation of the ordered pairs, and with the help of comma or and round bracket we can recognize that this is the ordered pairs. An ordered pair, this is the first element means x, and this is also the first element x. This is the second means we can say that the second number, this is y, and this is the second y. So x can be kept equal x because here is the equation of the ordered pairs, and y can be kept equal y. So means if here is 2, so this ordered pair will be equal, of course. If here is 2, so here also should be 2. So what should be the value of A? Without solving it even, you can tell that the value of A should be 6, because 6 minus 4 can give you 2. So hence both the ordered pairs can be equal. Similarly, 6 minus 2, you need here what? You need here 1, as here is 1. So what should be subtracted? Means here is not 6, here is B. Let me rectify the mistake here. This is B. So the value of B should be what? Of course, the value of B, if it will be 3, so 3 minus 2 can give you 1. So you can solve it here. A minus 4 can be kept equal to 2. B minus 2 should be equal to 1. So when you will shift 4 to that side of the equation, it will be plus 4, and you will get the value of A 6, and similarly the value of B will be 3. So 6 minus 4 will give you 2, and 3 minus 2 will give you 1. So hence both the ordered pairs will be equal if you will find the value of A and B. Okay, the second part here, 2A plus 5 can be kept equal to the first ordered pair here, the first element of the ordered pair here 7, and 3 can be kept equal to B minus 4. After comma we have the second number or the second element. Okay, here 5 can be shifted to that side of the equation, and it will give you, okay, here it is plus 7. Okay, here it will give you, that is fine, that if it is 7 plus 5, I think there is minus sign then. Let me rectify the mistake here. It's minus here, so it will get plus to their side of the equation. So 7, 8, 9, 10, 11, 12. So then it will be 12, and the value of A can be 6, because if you will put 6 here, so 6 2s are 12. 12 minus 5 will give you 7. So this is the minus sign here. Fine. Next is here 3 is equal to B minus 4. So you can see that okay, B is here, and minus 4 when brought to that side of the equation will be plus 4. So the value of B will be 7. So if you will put instead of B 7, 7 minus 4 will give you this 3. Let's go with the third part here. 3 minus 2A can be, this is equal sign here, can be kept equal to A minus C, whereas B minus A will be equal to 2B plus 5, means first element equal to the first element and second equal to the second. Here you are going to combine the like terms. Minus 2A, A should be brought to that side of the equation. It will be with minus here, and this is equal sign here. Minus 7 and 3 is with plus, so it will be with minus here, then their equal sign is missing. Okay, minus 7 minus 3 will give you minus 10, and here minus and minus will get cancelled. When 3 will be shifted to that side of the equation, it will be in division then. Okay, minus 2b from 2b, if you will subtract 1b, so you will get minus b here, and 5 plus 1 will give you 6. Now you don't want minus with b, because you just want to find the value of what we say, positive p. So even you can multiply both sides with minus in order to make it plus, so you will get minus minus, this will be positive and this will be negative. Or either you want to do directly, so b, you will shift to that side of the equation, it will be plus, and 6 to that side of the equation, it will be minus. Then here we have question number 4. Find the sets x and y if x into y is given a and b with a, then c with a and d with a. Here what you can observe that the Cartesian product is given and we are going to find the sets. Means it is the inverse of question number 1, where the sets were given and you were supposed to find the Cartesian product. So here the Cartesian product is given and you are going to find the sets back. So you know that the first elements of the ordered pair is the elements of set X, whereas the second elements of the ordered pair is the element of set Y. So from here we can make the set X as A, B, C and D are the elements of set X, whereas the A and A are the elements of set Y. As we know that in sets, elements cannot be repeated, because if you repeat the elements, because if you don't repeat the elements, so it will fulfill the purpose. So therefore we don't repeat the elements in set. So if it is a and a, so if you write it one time, that will fill the purpose. So if you can go reverse and you can check it, that a with a, then b with a, then c with a and d with a, so you will get the answer back. Here we have question number 5, the last question of the exercise. If set x is equal to a, b, c and set y is d, e, then find the number of elements in x into y and x into x. Let me tell you here that we are not going to find the Cartesian product here, rather we are just going to find out the number of elements in the Cartesian product. So we are just going to find that number of elements in set x is how many elements? 3. Number of elements in set y is how many? 2. So number of elements in x into y, how many elements will be here? So of course, how many elements? We will be having 6 ordered pairs. So 3 2s are 6. This is the method to find the number of elements in the Cartesian product. Similarly, you are supposed to find x into x. So of course in set x we have 3 elements. Again, if we have in set x 3 elements, so 3 3s are 9. So in x into x the number of elements are 9. You can do it yourself. Here we have your assignment here for today, which is exercise 5.3, question number 1 till 3. Question number 4 we are going to skip right now. We will do it later. Okay. And question number 1 till 3, the presentation is given by the students. In the first session we have done it, and then you have to go with exercise 5.4. Means this exercise you can take the help of again video and this lesson, and you can easily then do your homework. This is all for today. Have a nice day and stay blessed.